Hello, I am Neha Mevani. I am here to present the problem statement title, that is Object Level Change Detection in Colorized SAR Imagery under the Space Technology theme. The team ID is 59324 and the team name is Indie Sentinels. India, being the largest developing country, faces rapid urbanization, deforestation, and very frequent disasters. Conventional SAR images provide all weather and day data, but it is the grayscale image that is very hard to interpret, so it limits the timely decision making for the urban planning and the disaster responses. So what our project provides it, that it provides the AI powered system that transform that SAR image into the colorized optical like image using pix to pix gen. Then the changes, object level changes are detected using the Siamese CNNs, that is changes in the forest, buildings and roads, segmented using the segment anything model, which is used for analyzing the objects very precisely, and the data is taken from the Indian satellite data, that is the reset cartoset or the NISAR, that covers almost the entire urban and rural areas. So this is the technical flow of our project. Firstly, the grayscale SAR image is taken as input, and then the image is pre-processed. It means that all the noise and the unnecessary data is removed. It is then divided into multiple patches. Then those patches are used as input in the pix to pix gen. The main use of pix to pix gen is to generate the colorized image that was initially the grayscale, and then the colorized SAR image will be generated, which will be then used by the Siamese CNN, which will actually perform the change detection, and the change detection will be performed, and then the SAM model, that is segment anything model, will be used, and that will analyze each object very precisely, and the final outputs will be generated. So how this model actually works is, this is the pix to pix gen architecture. It actually had two main components, that is a generator and the D is discriminator. The main aim of generator is to generate the fake images that look like the real images, and the main aim of the discriminator is to distinguish between the real and the fake images. So generator generate the fake images using the unit architecture, and then those fake images and the real samples are then used as input for the discriminator. It is a patch gen. It means that the entire image won't be used in the input, but the single patch of the image pair will be used as input, and then each patch of the image will be tested as the real or fake, and then based on the loss it will be retrained again. So this is how the fake samples are getting generated. This is the unit architecture where image goes in this flow. Image starts from here as in this input layer, and as it goes downwards the size of the image decreases here, and as it comes here the image is in the smallest size, but the features of the images are most here, as it means that most abstract and complex features of the image will be abstracted in this bottleneck part, and then the image will go upward towards this U, and then the image will be, as image will be present here, it will be in its original size as it started here. So that's how the unit architecture will flow. After this, I just want to give the overview of Siamese CNN, the change detection model. How it works is that Siamese CNN takes two images as the input images, then it converts these two images into the vector forms, and then it checks the similarity between those two vectors based on the similarity metrics like the Euclidean distance or the cosine similarity, and based on that it detects a change out of that image. So that's how the Siamese CNN will help in change detection. And for the feasibility and viability, as these models are open source models, so these will be very freely available models, and also for the data, the Indian data will be used from the Bunidi portal of the ISRO, and then this data will be validated by the OpenStreetMap. I just want to show you the working of the Bunidi portal. Yeah, this is how the portal is there. You just need to enter the location. I have used the Ahmedabad location, and it automatically gets the coordinates of it, that is the latitude and longitude. For the area kilometer, as you can see this red boxes, it covers the area of 10 kilometer, but we can change it according to our needs. In the filters option, we have to do some filtering. We will be having the open data, it means the freely available data. The resolution can be ignored here. Similarly, for the imaging spectrum, it is not important. Yes, but for the satellite, as we saw the reset data here, yeah, this is the reset satellite, but the reset satellite only had the data up till 2016. After that, it was enclosed within EOS-04 satellite that has currently all the SAR data in it. And in the sensor type, we will be choosing the SAR sensor, and for the satellite sensor, we will be using the open source data. These are some of the options. As you can see, CRS means the quartz resolution and MRS means the medium resolution, and we will be choosing this option as this data is very it is already pre-processed and clean data, so we can directly use it. And then I'll click on submit button. So as you can see that the patches are getting generated, and from here I can just preview the SAR image over here. As you can see that, so this is how the SAR image will be used. And to use this data, I will be using add to cart option. So I have added the data into the cart, and now you can see the download option to download this data, and I have already kept it for downloading. So this is how the data, Indian data, will be used by the ISRO's Bunidi portal hub. These were our data sources, and for the viability, the target audience will be the Ministry Housing of the Urban Affairs, the urban development, to track the urban development. NDMA, that is the Disaster Management Agency's defense, to track the activities and monitor the defense, means the border sites, and ISRO and the state forest departments to track the deforestation and the forest growth in the areas, critical areas. And also, as this SAR imagery, that is SAR satellite, is all weather and day night, it will even be working under the most fog areas and in the cloudy weather. So we will be getting to know the update of entire, as a nationwide monitoring will be there. And this is the impacts and benefits. As you can see that this was the grayscale SAR image, it was then colorized, and then objects were segmented, that is the segment anything model. As you can see that the water, this is the land area. Out of this land area means we are assuming it as an island that is there in the middle of the water, but as you can see, as the image moves further, the island is not present in this F image. So we can indicate by this that the environmental changes would have been there that made the water levels rise and destroyed the entire island, or we can assume that this is the after a disaster, the entire land has been destroyed. So that's how we can just keep the track on the entire nation. OpenStreetMap validation will be there. For the validation, as you can see that green part is the land part, and then pink are the roads, and then these black are the buildings. So that's how the validation will be done through OpenStreetMap. These are actual results of our model. As you can see, these are the grayscale images. These grayscale images were then converted into RGB images using pix-to-pix gen model. Gen is generative adversarial network model, and using these model we segmented the image out of this. As you can see the segmentation of the images, and these are the segment anything model is available, that is the GeoSem model, which separates the vegetations and buildings and roads out of it. So that's how the model is working. And for the statistical result, we had the accuracy of about 78%, and that also touched the accuracy of 85%. Yeah, these are the parameters that were there in generator and discriminator. So these are the number of parameters that it is trained on. And for the images, there are total 1600 pair of images that was trained, and these are actual output of our model. As you can see that This is the input grayscale image, and the corresponding real image was there in it, and this is how our model generated it. You can see how well the model is there. Means the aim is to make increase the difficulty of the discriminator to differentiate between real and the generated images. So that's how the model is working. So I hereby conclude that keeping the track on such a big country like India and all its development activities in every field and domain is very difficult. So we just propose a solution that automatically detects the change in agriculture, in deforestation, in constructions, in urban planning, in rural development, that just reduces the work of the decision making and can improve the timely decision during the disaster responses and the thereby monitoring the national security and development of the country. Thank you.